It's a great pleasure to welcome you all to this open event. My name is Vivek Dua, and I am Deputy Head Education. I look after all the undergraduate and master's taught programs in the department. Today we have a group of very devoted people to this digital manufacturing of advanced materials MSc program, who will be taking you through what it involves and so on and so forth. I won't spoil what is going to come, and just going to say a few things about myself. I've been in London for 27 years and at UCL for 20 years of those 27 years. And it's been a great journey for me. And I hope it's even a better one for you. And with that, I'll hand over to Dr. Max Besenhard, who is the program director for this MSc program. And a warm welcome once again. Max.
Yeah. Good morning, Vivek. Very much. Thank you for the introduction. And I have the pleasure to introduce not only myself, also my colleagues who are with me today. That's Reza and Solomon, and as well as some students. You have the chance later to ask questions to directly. And I'm honored to have the chance to present to you our new program, our new MSc program called Digital Manufacturing of Advanced Materials. So let me share some slides with you, which I hope you see in a second. And if you do not, please shout now. Otherwise, I assume you all see the slide deck.
We can see it, Max. We can see it.
Perfect. Good. So as Vivek already said, I guess it's clear from the name as well, we are the University College in London. We established in 1826, so quite a long time ago. And it was the first university in England to admit students from any ethnic, class, or religious background, and the first to also welcome women on fully equal terms to men. And I guess that's also why we call ourselves London's Global University. We're the first in England to teach experimental science, modern European language and law, and till today, of course, we provide excellent and relevant research and teaching to the world. So mentioning teaching and research, so as you know, UCL is a top 10 university. They're ranked 9 by the QS World University Ranking in 2024. And we're also #1 for UCL's Institute for Education. And we have been awarded the University of the Year by the Times and Sunday Times Good University Guide. And we're also a top-rated university in the UK for research strength. For example, some results from the recent excellent framework are shown here on the right. And we also are proud to have several Nobel Prize winners, 30 in total, who are aware students or academics at UCL. Most recent one in 2020 is Professor Sir Roger Penrose in physics. This MSc program is embedded within the Department of Chemical Engineering. But of course, the science and engineering are very interdisciplinary fields. So we are embedded in the Faculty of Engineering Sciences, and that includes biochemical engineering, our Department of Chemical Engineering, and environmental and geometric engineering, medical physics, science and technology, computer science, electronics, and electrical engineering, mechanical engineering, as well as the School of Management and Security and Cyber Science. So as you see, what we do, and we're not an island on our own, we're well embedded in a very fruitful interdisciplinary research and teaching environment, and your students would certainly benefit from all these links and connections. So that is us, and with us I mean the Department of Chemical Engineering now. A bit of information on this department. So we are hosting in total 5 different MSc programs. For many years existing are the Chemical Process Engineering and the MSc in Global Management of Natural Resources. And very new, I mean, we're 1 year old. We're now teaching the very first cohort. So if you would join us, you would be part of the second cohort starting in September, October 24. That is Digital Manufacturing of Advanced Materials, Nature-Inspired Solution, and Advanced Propulsion. And all of them are hosted, all these 3, the latter, are hosted on the new campus, which I will present to you in a few slides. Just to give you some numbers, we have around 530 undergraduates. We have obviously a much smaller number, just about 100 postgraduate MSc students. We have around 200 postdocs and PhD students, and academic staff, just not 50, of which 22 lectures are dedicated solely for teaching. We have holding the Athena Swan Gold Medal. Yeah, so please have a look what that means and how it proves our commitment to gender equality. And if you want to try some taster lectures as well, there is a chemical engineering taster lecture series on our YouTube channel, to which the link is here. So what do we research on? Well, our core activities in the department focus on catalysis and reaction engineering, electrochemical engineering, molecular engineering and thermodynamics, multi-phase systems, nature-inspired chemical engineering, product and process systems engineering. So again, that's a very wide-faceted research environment, and that is also what we are teaching. So all these interdisciplinary links from computational tools to very accurate chemical and material science analysis and characterization with all kinds of applications in mind is very much the heartbeat of what we're doing in terms of research and teaching. So how old do we think we are? Well, I think I gave it away. I mentioned before how old UCL is. We were established in 1826. The department itself is not that old, but still we are probably the oldest chemical engineering department in the UK. And we are celebrating our centenary. So we are 100 years old. So we are there since 1923. And if you want to learn more about the long history of the department, I would recommend to have a look at our centenary videos and all the other links, information provided on our website related to the 100 years of UCL chemical engineering. So where are we? Well, that might be news if you're familiar with London and you already know what UCL is and where we are. So you might think of that. That is what many of us call now the old campus. That is the Bloomsbury campus. That is very central in London. It is just beside the British Museum, if you want. Oxford Street is also not far away. You might know that from do some shopping. Also just beside our University College Hospital. But since 1 year, now we have operated a second campus. Yeah, that's UCL's biggest extension for quite a while. And that new campus also this year might seem familiar to you, especially if you followed the 2012 Olympic Games in London. So this brand new beautiful campus is built right at the heart of this Olympic Park. You might also know things like the London Stadium, just in our neighborhood, as well as, of course, the very famous Westfield Shopping Centre. It's a really beautiful area, really nicely what happened there in Stratford. And that is the campus we call UCL East, the campus in East London. So that is how it looks. As I've mentioned, it's a really beautiful place. It's a wonderful place to commute to. And of course, we have fantastic research and teaching facilities, which I quickly show in the next slides. But it's obviously much more than this. The entire campus is part of a hub for education, culture, the art, and commerce in Stratford. There are 9 UCL faculties working there. We have nearly 60 new interdisciplinary degree programs, of which the one I present today is one, and it's also part of London's East Bank, which is a new culture, education, innovation, and entertainment district. And very important, the building, which you see here very dominant, is home to the Manufacturing Futures Labs, which I present because for very good reasons for this MSc program in a few slides as well. So these are some images we shot. Just to let you know, the building was opened just a few months ago, so in September 23. So everything is absolutely brand new, and of course, absolutely cutting edge to be ready for you and our research activities. And we have great teaching facilities, high-end computer clusters, and a lot more. And then what I mentioned before, the Manufacturing Futures Labs. We have the penthouse if you want, so the 7th and 8th floor of this building gives us the fantastic multidisciplinary research space we need for that kind of research and teaching activities we are doing here. So these are images from the Manufacturing Futures Labs, or the adjacent wet labs, that's how we call it. And as you see, these are unique laboratory facilities that are designed for teaching. Yeah, so there are facilities for research and as well as specifically designed for teaching, because obviously we need different infrastructure for both. This is more on the research side as well as the teaching side. So you see high-end see-through fume hoods. We have multi-floor facilities that can also host industrial scale equipment. And we have dedicated labs for automation, electronics, and in general, massive research facilities, and much more. And what you benefit from this, well, of course, you have, since we have the penthouse, as I mentioned before, you have a very nice view over London. What you see here is the London Stadium, and in the background, you see the London skyline. So this is Aldgate, with all the famous buildings. And as I mentioned before, you are really integrated in these research labs. You have also the direct interaction with top international researchers. Without going too much into the details, what the MFL is, it is the center which is shared. Yeah, these labs are shared between chemistry, chemical engineering, biochemical engineering, and mechanical engineering. So it's a truly interdisciplinary space where science and engineering comes together to promote disciplines such as AI and machine learning, data mining, very much automation, robotics, green chemistry, life cycle analysis, nature-inspired engineering, process intensification. And this is obviously facilitated by the fantastic facilities which we are ramping up here. Our neighbors as well, very important for this program, is the Center for Robotics and Autonomous Systems. So why I'm mentioning this? Well, I'm mentioning the Manufacturing Futures Labs because this will be the home to the Digital Manufacturing of Advanced Materials MSc program. But now we can talk, now that we talked a little bit about UCL and the department itself, I'm going to present the details, the very specific details of this MSc program we're discussing today. So why doing this? What is digital manufacturing? What are advanced materials? Well, in order to explain you this, let me also explain what Industry 4.0 is, or the fourth industrial revolution. Yeah. So you might remember from your textbooks in high school what the first industrial revolution was. That was end of the 17th century, and technologies such as the steam engine or ways to produce textiles simply changed the way of society. We changed how we produce goods, how we manufacture goods, and that significantly changed the lifestyle we had in the 17th and 18th century. You might also know of the second industrial revolution, beginning of the 19th century, together with communication, transportation, and of course, the rise of electricity. How that has changed the world since then. You will be very much aware because you grew up in the third industrial revolution after World War II, how it happened that computers, integrated circuits got cheaper and cheaper, and that allowed computers to take over the world. And today we cannot even leave our house, get a train ticket, etc., without our little computers in our pockets. And of course, also part of this industrial revolution, or the digital revolution, end of the 20th century, is how robotics and robots started to take over the manufacturing sites. Yeah. So as you can see, we call something an industrial revolution whenever new technologies are changing the way we research and we produce, and we develop and we manufacture the goods we need for our daily lives. And this is the fourth industrial revolution now. So what are the new technologies that are changing the way we produce goods? Well, we call them smart technologies and digitalization, and they're radically changing the way new chemicals and materials are developed and produced. And what we're speaking now within Industry 4.0 is how automated processes and robotic systems allow for operator-free experimentation and material development, and of course, the big problem of optimizing these materials. We will speaking about how computational tools such as machine learning, artificial intelligence are empowering this. And that leads to the new paradigm shifting scenario towards, as I mentioned, what we call is digital manufacturing. So we want that is a very broad term, how computers, computational technology, smart algorithms combined with hardware enables us to do things we haven't been able to do before, and go beyond the traditional and labor-intensive manual experimentation. So that was hopefully the part of digital manufacturing explained. So let me give you a bit of a background on the advanced material side. Yeah, I guess you're all aware of the big challenges we're facing as a society, about the new demands we have for energy generation and storage, the new demands we have for healthcare and medicine, and the new demands we have for sustainable processes, development and manufacturing. And at the very bottleneck for us to overcome these challenges are the demands for new materials. So we need new materials to develop and produce that are advanced. And what I mean, just to give you some examples, we're speaking about new drug molecules. I think you saw and you remember from the pandemic how important that was and how much development and manufacturing had to be speeded up and how much speed was really crucial for us to get our normal lifespan. We're talking about nanomaterials for healthcare. We're talking about, for example, magnetic nanomaterials that could cure cancer. We're talking about very complex multi-metal catalysts that make processes greener, energy efficient. And generally talking about new fertilizers and new materials we need desperately for solar cells, for wind energy generation, for energy storage, for hydrogen storage. And I could go on and on how new materials, advanced materials, are very much at the heart of what we have to develop and also mass produce to make sure we're going in the right direction to tackle the big challenges of our planet. So what is the motivation for this specific MSc? Again, the MSc for Digital Manufacturing of Advanced Materials. So now we have the digital manufacturing and the advanced materials part combined. But it's very important to mention that this is not only our idea, it was developed with our industrial partners, which very much expressed the need that we need to equip the next generation of engineers and scientists with these interdisciplinary skills which they are lacking. Yeah? So these skills are highly sought after in industry and academia. And what I mean with these skills, just to give you some examples, is material science, advanced materials, as I just mentioned before, as well as robotics, flow chemistry and high throughput experimentation in general, automation and autonomous systems, optimization, design of experiments, and of course, very much machine learning and artificial intelligence. And in general, combined to this, also some programming skills. So this is what we're aiming to teach you in this MSc program. I'd like to use another analogy. Yeah. So we are not only teaching you in this MSc program the computational tools for statistics, data analysis, and I already mentioned machine learning and AI. We also teach you experimental tools in the material science side. We're talking about robotics, flow chemistry, nanotechnology, and advanced materials. And here is very much where we have the influence and input from our industrial partners. We also teach the bit in the middle. Yeah. So I use the beautiful Tower Bridge in London here for this analogy. What makes the full show possible and allows us to open these opportunities is that we also teach automation, high throughput experimentation a bit more later, but we really go in the hardware. We learn how computers communicate and interact with the hardware, because that is what makes smart development and manufacturing possible. And this is very much the key we are unraveling here in this MSc program. Why should you be bothered doing all of this? Well, in very simple terms, it is good if you're good with computers. It is good when you know machine learning. As you know from the job market, these skills are very highly ranked. It's also good if you are good in the lab, if you have experimental skills, but you really have a competitive edge if you have knowledge on computational as well as lab skills. And it's just mentioned the very important bit that connects the two of them. So that certainly gives you an advantage over your peers. So how do we help you to get this competitive advantage? Well, this is the program structure. Yeah, so it's a 12-month program where we teach you in term 1 the very basics. Term 2 is sometimes we call it the fun one, so you spend a lot of time in the labs. And term 3 is then we have some assessments there, and of course your big final showstopper, the MSc research project. But let me explain a bit more. In term 1, as I've said, is that term where we teach you the basics and the fundamentals to be able to start this journey. So term 1 starts with a module on high throughput materials chemistry, where we talk about the synthesis and characterization. That is the module I'm teaching myself, and we will speak about material properties, how they relate to the building blocks. We speak about the synthesis, the analysis, and of course the applications. Already mentioned things like solar cells and semiconductors. We also have a very specific sessions on nanomaterials, as well as the high throughput experimentation on things as flow chemistry, robotics, lab automation, So we get you up to speed here with the fundamentals of these disciplines. As well in term one, you will also get up to speed with the fundamentals of data science, yeah? And we talk about statistics, data acquisitions, and this is really what you need to understand first to then be good in machine learning and artificial intelligence. So we start, and I think this is very important for you to understand here. We do not expect our applicants at the first week, we do not expect you to have any knowledge of coding, yes? But we obviously expect you to have a motivation to learn them. So it's fine for us if you start at zero, but you will learn this. So the first weeks of this module are dedicated very much for you to learn coding. And we also use something like the Coding Academy, which gives you the chance to learn on your terms, on your time, online, whenever you have the time and quite frankly, the motivation to improve your coding skills, yeah? So as I've said before, once you have these basics of statistics as well as coding, you can then advance to the really exciting bits of machine learning. And so you will then hopefully understand the images I'm showing you here, such as the artificial neural network on the bottom right bit of the screen. Good. The last fundamental bit that is taught by Lauren, which you see here with her molecular building blocks, that is the applications of digital materials manufacturing, yeah? So we showcase research and development, so all the things you learned before about the fundamentals of materials, the fundamentals of data science, how they come together, and how they actually, one empowers the other. And what Lauren will speak about how AI meets material science, what reactions are optimized, for artificial intelligence is determining molecular properties, and she'll also give an introduction to topics such as digital chemistry, how we can design molecules on a computer, and how we can actually make molecules using robotic tools, yeah? So Lauren here in the picture has the great pleasure to teach you these high-end applications. Definitely worth mentioning here is that I mentioned before that the program was co-developed with our industrial partners, because that is what they're working on. These topics are what they are lacking skills, what they're trying to recruit. And it also helps us to work directly with industrial partners and to work directly with industry, meaning that we are very privileged to have fantastic industrial guest lectures. What I show you here were the industrial guest lectures we had for the very first term in one. So the lectures you see here were held between September and Christmas, and we had guests, for example, from big pharma companies, as well as Zeiss, Stolichem, and that really gives you the chance to get an insight on what they're actually working on, and of course also a way to discuss with them your own career opportunities after the guest lectures. The term two, I mentioned before, some of us call it the fun one. That is where you're going to apply all these fundamentals you learned in term one, and you start going into the labs. One of these modules is the automation and materials manufacturing one, where you learn about data acquisition, communication protocols. And if you remember the analogy I gave before with London Bridge, that is the bridge we're focusing on in this module. But before speaking too much, I'd like to hand over to Reza, who is right now in what we call the Innovation Lab. So I'll stop sharing my screen and hand over directly to Reza. So Reza, the floor is yours.
Okay, thank you, Max. I hope everyone can see and hear me clearly. I'm here in the Innovation Lab today. I just wanted to give you a quick tour of the lab and for you to get an idea of the great facilities that we have in the lab. So if I turn my camera around, so this is the entrance to the lab. As you can see, here is where we get the inductions when the students come in. In the middle, we have the collaborative space where students can work on any types of projects. Here on this side, on the other side, we have the 3D printers where, for example, we can use to print different stuff, for example, for mounting or for making closures for our sensors or electronics. So different kind of materials, different types of printers. We also have laser cutters on the other side, where again we can use for to cut using different materials in order to build mountings for example, Arduinos or sensors or final setup, maybe a nice closure at the end. On this side, we have the cutting and shaping lab. We can do all sorts of cutting on this side. On the other side of the lab, where a session is going on right now, we have the computational space, as you can see, around 64 PCs. And also on the other side, we have the PCB printing lab, where, for example, we can print the circuits that you have designed using computers in that room. Also, the soldering workshop is on the other side. So each desk is equipped with power generators, with oscilloscopes, and also high power PCs. For the automation module, for example, we use very simple, a small kind of electronic systems, microcontrollers, small sensors, in order to learn the basics of data acquisition, process control, and then also use the different models, data-driven models or mechanistic models, in conjunction with the hardware that we have. So that was my part. I hope it was useful. Let me know if you have any questions. Over to you, Max.
Perfect. Thank you, Reza. Just sharing my screen again. Good. So that was Reza. Thank you very much, from the Innovation Lab. Another module in term 2 is the data-driven materials manufacturing, or the integrated module. And that will be hosted not in the Innovation Lab. We have a lab here dedicated for teaching for topics such as robotics and flow chemistry. And that is a specific part of the wet labs just beside the Manufacturing Futures Labs. And what you see in the background again is the wonderful London skyline in Aldgate. But before teaching you too much and telling you too much about it, that gentleman here in the picture, that is Solomon. And I think at this point it's best for me to hand over to him, because he is right now in the manufacturing lab facilities I mentioned just now, to show you a little bit of what you will experience there in term 2. So Solomon, I hand over to you now.
Can you hear me now?
Yes, I can hear you.
All right, thank you.
You're not on the screen though.
Is that?
You're not on the big screen though. Now you are. Thank you.
Yeah. But can you also see the view of the lab?
I don't think so. The second camera, I see it on top. I'm not sure how the others see it, but I see you for the camera using right now. So maybe use that one to show the lab.
All right. So, okay. So I'm Solomon. This is one of our amazing teaching facility lab in this MSc program for the digital manufacturing of advanced material, which is part of the Manufacturing Features Lab. So in this lab, we have amazing facility where the students have first-hand information, how to use the skills they have acquired, like some of the highlights that Max have done in term 1 module, they apply it in this module. We have flow chemistry setup, which they use for flow systems. They learn how to see the basics of how flow system works and how it's being useful. And also we have facility for analysis. When synthesize material, we have state-of-the-art facility which you have opportunity to know how it operates and also use it to synthesize the material. And in this fourth industrial revolution, we now see that robotics is actually in the forefront of these processes. And so we have amazing robotic facility where students learn how to code as part of the term 1 module. Now you implement that in the robot, and as you can see now, the robot is going on doing some pipetting. So students with the code they develop, they will use it. We are actually experimenting with or showing you with some dice, but obviously this knowledge could be extended in nanoparticle synthesis. And in this synthesis, you'll be able to know how to do high throughput experimentation using the robotic platform. As Max have said, we don't expect you to have the coding skill at the go. And likewise, we don't expect you to know how to use the robot, how to operate it. But before the end of MSc program, you would have developed enough skills as what you can see how the robot is moving. You'll be able to code and instruct the robot to do amazing job. And these are the skills that is needed out there. So in this integrated module, it's a nice opportunity that you'll be able to get some highly sorted skills out there in the industry, such as the robotic. So I hope this was useful, and if there's any question, I'm ready to entertain it. That's it from me. Max, over to you.
Perfect, Solomon. Very nice to see the robots in action.
Thank you.
Good. So back to the slides. Again, you have to shout in case you do not see it. So that was Solomon from the robotic labs, which you will see and be very much working with, and all these tools in term 2. And in term 3, as mentioned before, this is the showstopper where you will work in individual research projects under the supervision of a member of the academic team in the department. And the aim for you here is to develop and enhance your abilities to guide a project and deliver results. So this is where you will work, of course, under close supervision, independently to demonstrate us that you are mastering, quite literally, the skills of digital manufacturing of advanced materials. And if you have a computational project, we have a bit more flexibility, but for those requiring experimental work, this will be held during the summer in the Manufacturing Futures Labs. Something I mentioned not so far are the optional modules. So I did mention at the very beginning that there are also other MSc programs around, and that allow us to, or will allow you to pick certain modules also from these programs. For example, the nature-inspired materials engineering, advanced characterization, electrochemical materials, etc. These are optional modules you can choose either in term 1 or term 2, as well as that I would say that the technical skills related, maybe a bit more on other skills, also entrepreneurship, social skills. That is from the second optional module catalog. That's the catalog B. You can pick things like sustainability and decision making, find your future, entrepreneurship, theory and practice. So whatever you're interested in, either sustainability, life cycle analysis, how you find which job is best for you, or entrepreneurship in general, whatever your interests are, you can pick the right optional module that suits you best. How do we teach and how do we assess? Well, the pandemic is over, so all the teaching will be face-to-face, and not least because we have this very beautiful campus here. That will include tutorials, workshops, laboratory practicals, and of course, what we give here face-to-face in our lecture theaters and these amazing laboratories will always be enriched with online materials and activities. We have still these online materials for you. For example, the Coding Academy I mentioned before, so that you can work on these things based on your own schedule. All the lectures we give are recorded, by the way. We have something called lecture cast. Every lecture you can watch afterwards as many times as you want on your own time and your own pace. Assessments will be typically a mix of coursework, reports, project exams, group work, and quizzes. And very important to mention that for each module, there will be some kind of formative assessment, meaning it is not, you don't get grades on this, or you do get grades, but they do not count. So the idea of this formative assessment is that you can test yourself if you're ready or not for the one assessments that then count for your grades. Who are we? Well, 3 of us you mentioned so far. We are 6 in total, and that is the program team, which I'm showing you here. It's myself, Payman, Lauren, Izzy, and Reza and Solomon, who just presented the labs. And I would say we're all very experienced in that field, as well as with industrial experience. So we, especially for those of you who are also seeking for industrial career, I think we're very well equipped to also advise you on that front. Having mentioned that, so what do you do after? How do we help you also to find the career that's really suiting you? Well, you have the full support of UCL Careers team with dedicated workshops on how you prepare a job application, for example. There is a dedicated workshop on career opportunities just for the students of the Digital Manufacturing of Advanced Materials MSc. It's very much dedicated for job opportunities for the education you get in this MSc, and you will see them already in your first week, an induction week, which we'll have in September 24. You already get into touch with the UCL Careers team. And do not forget, as I mentioned before, we have several industrial guest lectures throughout the program. The ones we gave or we had in term 1 are listed here. And after each lecture, there is also a Q&A session, of course, depending on how many questions you have, but that will give students the way to interact directly with industrial partners and to do a bit of networking there and explore also possible career opportunities with our industrial partners. Careers, well, I mentioned in my first slides that these skills are in high demand in industry. You don't have to take my word for this, and when you're picking an MSc or in general education, I would always recommend for you to do the following. Have a look in the job market. Have a look which jobs you would like, which jobs do you find interesting, and by all means also consider the salary. And then have a look how competitive you would be or you could become for these jobs. Some jobs, I went on these job sites the last month. Some jobs I picked here. I've listed them. I also cited here at the bottom some of the lines they're looking for. And as you can see, these computational skills, especially combined with skills in automation, material science, and laboratory equipment in general, they're really in high demand. And many companies are looking specifically for graduates and people which have that skill. So don't take my word for granted. What is really in demand in industry, have a look yourself in the job market. I also mentioned that the skills and what we're teaching in this MSc program is in high demand in academia. Again, do not take my word for granted. If you want an academic career after an MSc, you will do a PhD most likely. So have a look which PhD topics are advertised. What I'm showing you here, these were the PhD projects we had advertised in January. Yeah. And as you can see here, all the titles are very much related to things such as advanced materials, machine learning, as well as automation. Yeah. So this is my proof. I would say that the skills we're teaching here are very much in demand in academia as well. Why London? Well, that is a good question and very easy to answer. Vivek mentioned as well at the beginning. We have that saying here, if you're tired of London, you're tired of life. And I would say once if you manage to make a move to London and you can live here for a while, you will know exactly what that saying means. Also important to say, there are various scholarships and bursaries you could apply for. Some of them are listed here. Please use the QR code to go to the ones provided by the faculty in UCL itself. We also have departmental ones. Those are scholarships awarded by the department itself. We have one for academic excellence as well as for financial needs. So that would cover partially the costs of this MSc program. And the links are provided here. So if you need further information, if you're eligible, how to apply, please contact us or go directly to these links provided here. So very important before I close the session. So for whom is this program? But I guess it came clear that it's very interdisciplinary. And if you are absolutely brilliant in coding, if you know robotics, if you know automation, electronics, if you know material science, then you would not need to study this because we already have these skills. However, for everyone who is probably good in one of these things, but is lacking skills in the other, I would highly recommend this program. And that's why we are open for students from various disciplines, not only chemical engineering, for example, biochemical engineering, electrical engineering, electronic engineering, mechanical engineering, material science, computer science as well, that's not mentioned here, chemistry and physics, environmental science, and all their allied fields. Yeah. Just to give you an example, if you are good in material science, but you haven't done machine learning or coding, you might find one of the modules easier, you might have to put more work in the other. And that goes the other way around. If you're an excellent coder, if you have already touched machine learning, you might find these modules easier, but then of course you would have to put a bit more effort on the modules on material chemistry. So there is, if you have already industrial experience, we already welcome this. So usually we have as all or most UCL MSc programs, we have a minimum of an upper second class bachelor degree for universities or an equivalent if you come from overseas. If we have industrial experience, there is a minimum of only a lower second class bachelor degrees from UK University or something equivalent. So we very much promote people from industry due to their experience to join our program. So before closing the session, I would like you to stay in touch, and more information about this MSc program can be found on our prospectus site, which is the first link given here. So there's a very detailed explanation of what we're teaching, how we're teaching each module, etc. Any questions you have, please feel free to reach out to our department's postgraduate team. The email address is here, and very much to myself as well. So m.besenhard@ucl.ac.uk is the email address that reaches directly to me. And please follow us also on Twitter, Facebook, LinkedIn, Instagram. So that are the links for the chemical engineering department. A few more videos about the program. We have a program video that in a few minutes tries to explain what I tried now in half an hour and a bit more. And also a lecture we had for Spring into Science Technology, which we gave in, we raised together in March 23. So that is a lecture called Smart Manufacturing in the Digital Era. And that is very related, very much in line with the topics we're teaching in this MSc program as well. So I highly recommend, of course, these videos. And before we go, I would like also to take a couple of minutes to complete a short survey about your experiments for the event today. So that is the QR code that will link you to that event. So I'll leave this up for 10 more seconds before closing the session. Sorry, not closing the session, finishing my presentation and then starting the Q&A session. So having done this, last thing for me to say now is to say thank you for your time, and ask you the big questions. What do you think? Do you have any questions? What would you like to know about UCL, UCL East, and the program itself? I stop sharing and I say thank you very much for now. So I hope you still hear me. Well, means you can unmute yourself, but you're very welcome. That might be the most convenient way if you would use your the chat function to ask us the questions directly. But maybe before we get our first questions, I could give the spotlight to our MSc students, and I will ask them. So Kui, Ji, Lichi, I hope you're doing fine. So why do not I ask you if you could tell us how you like your student experience in the Digital Manufacturing of Advanced Materials program so far, now that you're 1.5 terms in almost. Don't forget to unmute yourself.
Yeah, hi Max. Could you hear me?
Loud and clear.
Hello? Yeah, I'm happy to answer these questions. So for me, I'm really loving this experience, and I think it's super practical. In the first term, we have already covered some theoretical knowledge in chemical engineering and material science. And in the second term, we got into some practical courses that perfectly blend theory with real-world applications. So for me, it's both fun and challenging, and I can already see how these practical courses are closely integrated with industry needs, which means I think I can apply everything I learned when I start my future job.
Thank you very much. And maybe again, to all three of you, whoever wants to answer, how do you like the new campus? I mean, the building is now a few months old, and you were together with us, probably the first people entering these buildings. So how do you like the new campus and the new facilities?
Yeah. Hi, Max. Can you hear me?
Loud and clear.
Wow. So about the campus, I'm very satisfied with this new campus because it provides ample space and facilities for us to move freely. Also, about the teachers in this project are very approachable and fully considered the students as our learning progress and when we need extra help outside of classes, we can also contact our personal tutor, like Reza, and he can provide us with appropriate assistance. So I think that's very great.
Thank you very much. Maybe a last question to the three of you, and whoever wants to go first. This program is very interdisciplinary, yeah? So you are learning about a mixture of topics such as machine learning, advanced materials, and robotics. How are you finding this mixture? Is it difficult for you? Are you enjoying the mixture? And maybe you could share your experience on this interdisciplinarity of the program.
Hi, thank you for asking. I think for this combination, I need to say more because I'm working in mechanical engineering, but now I'm studying in more like materials and chemicals, and I feel very good because the tutors can explain the knowledge that I haven't done before very clearly, and that helps me studying these parts that I have never learned very well. And I can also ask questions, and they will answer them very detailedly, and that helps me a lot. Yeah.
Thank you very much, Bruno.
Thank
I
you.
saw we got one question as well in the chat, and that question was about funding opportunities for international PhD students. Again, this event today was for the MSc program. There are funding opportunities for international PhD students. I would recommend to reach out directly to our PhD admission teams, which you find the link on the CamEng website. But as I mentioned, for depending where you're from, there are probably national funding routes. There are positions in the UK which also cover international fees. Again, it depends where you're from, where you're applying from. What I showed you today was how the topics we're teaching in this MSc program are very much in demand, as well in academia. So hopefully that's the idea, that you will be very well prepared for these PhD openings which we will have at UCL, at CamEng in the UK in general. Again, for ways to fund PhD students, please reach out to the separate channel, and that's a different discussion we're having here. But of course, there are always opportunities. If any more questions, please use the chat, unmute yourself, or whatever you feel is most comfortable to reach out to us. I would say in that case, Mark, I hand over back to you to close the session. And big thank you for joining today. And hoping very much to hopefully welcome you in September in our brand new campus in UCL East, hopefully for an MSc program as the digital manufacturing of advanced materials. So have a wonderful start into the week. Bye.
Thanks a lot, Max.
Bye.
Bye, everyone.
Bye.